So let's kick us off. This is just a quick slide to introduce our team. Like some of the other teams here, we have a great showing of diversity from all of the different undergrad schools and some of the graduate schools. Special shout out to Joseph Davin, one of our advisors on the team, super helpful. And we're working with Patrick from the Evite team. So as Reggie mentioned, Evite is, yes, it's an event planning sort of social platform. You send invitations over it. The business generates money by putting advertisements on those invitations. So executive summary here. As you might expect, right, Evite's event volumes and how they kind of generate money has been seriously impacted by COVID-19. In fact, Evite event volume has dropped by almost 50% this year. However, this kind of problem is very heterogeneous across the different types of zips and regions. We put together the Evite event data at the kind of zip level, along with some socioeconomic variables, as well as public health drivers, to really try to figure out what differentiates one zip from another zip in terms of how it's impacted by COVID-19. We think this sort of methodology can be useful going forward. And then one other thing we found was that actually the kind of relationship between event volume loss and COVID-19 cases is not really clear or evident. So I will quickly pass it off to the team then.
Yes, so we all know that this year we've had like a pandemic, COVID, and then this has greatly impacted COVID Evite business, and then it's decreased by over 45% since the start of COVID. However, rolling back to the past 2 years, we can see that Evite event volume follows a specific trend and is highly seasonal. Most events happening in the summer around June when there's graduation, and then also in general November, December, which is the holiday season. However, after March, because of the COVID, event volume appears to have decreased and remained around a baseline of around 200K, which we see is now flattened and almost there's no seasonality at all so far. On looking at the event volume on all the zips, on all the locations, like the previous slides, we can see that everything is basically predictable because of the seasonality. However, when we go to a specific geographic location using zip codes, we can see that different zip codes behave differently. Whilst others have some certain level of seasonality, others do not have at all. Whilst others seem to be affected by COVID, some have not. Like looking at Prince George's County, it seems like it hasn't been affected by COVID-19 at all. Other zip codes like in Beverly Hills, yes, they've been affected by COVID, but they seem to be on the rise. They seem to be improving. So this is generally how we see that different forecasting challenges that may come through in that certain geographic locations behave differently.
Cool. So this is just kind of the research questions that we had as we kind of progressed through the project. One was just kind of understanding the baseline and historical event volume, and also kind of processing the data. There was some data cleaning that we had to do to put it together. As Minash alluded to, right, we want to understand how zips are differently impacted by COVID, and what are really the drivers that kind of differentiate that impact. And ultimately, the final question was just like, how many events are at risk? Can we sort of quantify the number that we expect to lose due to COVID? This is just high level the approach we took. So there's a bit of data gathering. So we had the Evite data, we brought in COVID incidence counts, we brought in some COVID regulatory data, which is really interesting. So this is guidance around like what should be open, whether masks need to be worn in a county, and also some census socioeconomic data. We put all this together into a data layer and then ran a few associative analyses, did some clustering on the zips, and also ran a regression to sort of identify that event at risk variable that we're interested in. Real quick here, this is just kind of the data layer we've created. Again, it's at a zip monthly level, so we understand the events, understand the number of cases at that point in time, and also the sort of policies in place, along with some sort of other variables that differentiate zips. I will pass this to Ashley to talk a little bit about how we handled the COVID regulatory data, which I thought was quite interesting.
Yeah, definitely. So as Ming mentioned, basically our goal with that data was to get at any point in time an idea of how open the space was. So basically how much people were actually allowed to be participating in physical events like this. And so to do so, we used data that was obtained from the Department of Health and Human Services, which contained policy orders on the county or state level in which the type was something general like max requirement, stimulus spending, and then there would be a more specific text of the policy itself. The first step we did in cleaning up this data was rolling it up to the state level There were two reasons why we did that. One was because county level orders weren't actually present for all states, so that wouldn't have been consistent. And the second was that we noticed that on the county level, there wasn't any difference anyway, because as we might assume, this wasn't in control of the counties, it was really in control of state governments. So in order to obtain features, I did two passes of NLP. One was on that general policy type column that I just described, so that I just had a broad idea of what was in place at a time. If you look to the top right corner, NLP round 1 is what I'm referring to, where I followed standard procedures for NLP on this level, like standardizing the text, stemming, removing any intermediary words, and focusing on frequent terms. And once I did that, I was able to change those kinds of policy types into a binary variable that was 1 if the state had it in place at that time, or 0 otherwise. The kinds of policy variables this was max requirements, stimulus spending, stopping evictions, etc. But then we also wanted to add a quantitative dimension to this to see exactly how open a space was. So I did a second round of natural language processing, this time allowing for numerical features and percent symbols, actually focusing on them, coupling this with the features that I obtained from the previous round of natural language processing. I was able to map the results to a function that would categorize them and then extract the number to see how open or closed something was. And the outcome, as you can see there, was something like the general type of space, outdoor recreation or entertainment, and whether or not it was being opened or closed and to what extent percentage-wise. The difficult part would have been searching the context for whether or not it was opening or closing, but luckily the data set had that as a separate field, so this process was like much easier because of that. So our next goal, like Ming discussed, was to cluster the zips. Basically, we wanted to segregate the zips into those like however many categories there are based on their impacts that Manash pointed out earlier. Our first step was to do it purely based on the COVID data, and we focused on two variables. One was the year-on-year change in event volume, and the second was what direction that change is going in. Focusing on July and August, since those were the two most recent months in terms of our event data, we looked at what the percentage change was in July, what the percentage change was in August. If the percentage change was larger in August, that was kind of like a worsening severity, and that was a negative variable. If it was improving, that is a positive variable. Same thing for COVID impact. A negative variable indicates a decrease in event volume, and a positive variable indicates an increase. So our first step was to cluster just based on these variables. We attempted to do that with unsupervised clustering algorithms, mainly k-means, but what we discovered was that due to the high density in the center regions there, clusters 1, 5, and 4, the cluster results were often incredibly arbitrary and not too insightful. So instead, we turned to a manual kind of designation here. You can see we primarily first split on the 0 axis and then split within those. And our end result was 6 clusters, each having different impacts from COVID, both in terms of whether or not they were highly impacted initially and whether or not they are improving in that sense of impact. You can see that the main clusters, both in number of zips and driving event volume, are 1, 5, and to a lesser extent 4. So once we had these clusters, we wanted to gain insight as to what made them distinct from each other. To do that, we wanted to glean the feature importances, and our means of doing that was to run a series of regression analyses, obtaining the coefficients of those lines and using that as a positive or negative indicator, basically saying whether or not the average zip within a cluster is above or below the mean of a certain variable. So that graph is to the left here. And the way you would interpret this, the graph itself, or this table, shows the means. So cluster 1 had a mean of 141 cases per zip. However, that is a red number, so you know that is below the mean in the entire data set of cases per zip. So a general insight into this table, looking at like, let's focus on a couple of the more interesting clusters like 1 and 5, since they were driving most of the event volume. Both had a large COVID impact, but 1 is improving while 5 is worsening. 1 was one of our more wealthier and well-off clusters, as you can see by the fact that it has above mean percentage households with the higher income levels. And this makes sense because when we look at a couple of the zips that were in cluster 1, it was Los Angeles, New York, and things like that. Cluster 5, which was the other interesting one, had a lot of large cities just spread out in general that weren't necessarily like urban.
Yeah, We also looked at this just on a geographical level because we were interested in kind of the consistency across zips. But you can see based off the geoplotting, it's kind of scattered all over the place for each cluster. Kat, do you want to talk quickly about the associative analysis on this?
Sure. So as Ashray and Manash were just mentioning, such a big part of this project was accumulating all the data. And the next part that we're going to talk about is more of the associative and predictive analyses that we did. So this slide is just showing how there was a really small correlation among some of the variables that we spent time accumulating, specifically things like your socioeconomic variables, like percent white or percent over 65. The matrix on the left is showing that there's no positive correlation between higher COVID counts and event loss, which helped us to think more deeply about this story, that we don't think people are really reacting to events in terms of COVID counts, but that it may be something else. So Kevin's going to hop into some interpretation of the regression that he worked on.
Yeah, so basically, we set up a linear regression to try to predict event volume for Evite through 2021. So we did this for every single cluster of zips that Ashray found, and we used an indicator variable that was 0 or 1, depending on whether there was still lockdown through 2021 to help predict the model. We found that this was the most correlated feature compared to stuff like the number of COVID cases. So we also presented 2 scenarios for every single cluster. So the first scenario is if the regulations continue through 2021, and the second scenario is if the vaccine comes out in December 2021 and business returns to normal sometime in January 2021. Yeah, so then essentially what we did was we trained the linear regression on the first 28 months that we had, and then we back tested on the last 2 months. You can go to the next slide. Yeah. So then these are the forecasts for every cluster. We can see the forecasts are generally pretty good. In the case where there's like still lockdown through 2021, we see that like it still follows the seasonal trends, but the events are really like diminished in terms of event count. While if business returns to normal, you have this nice upward curve that will like have event volume returning back to normal sometime in November, December, and yeah.
Cool. All right. So just to wrap us up here, right? So I think our recommendations or conclusions from this project is one, again, zip event behavior is highly heterogeneous, and there's definitely opportunities for kind of clustering like types of zips, both trying to identify where the primary volume is to kind of prioritize maybe the marketing or sort of the retention efforts. Once those zips are kind of segregated, they are probably have some sort of unique and distinct features. We put the data together. We had a hard time finding out what those features are. But there's still work to be done here. And then again, the last thing which was surprising to us, is that there wasn't a strong correlation between the actual number of COVID cases and the level of event suppression. Of course, we only looked at 1 month, so we were telling the team, okay, there's probably other months of data. As we get more data, there's probably more ways to study this. So some of our preliminary findings. Yeah, and that's it from us.